What are hybrid vehicles? Hybrid vehicles, such as hybrid cars, uses two different power sources, either the usual internal combustion engine using petrol or diesel, or an electric motor that runs on a battery. So the control system of the vehicle chooses which energy source to use depending on the driving condition, either to use electricity, to run on fuel, or both. So electric vehicles are especially fuel saving because you can choose to use electricity instead of combustion fuel, and that reduces emission and it is good for the environment. It is also energy efficient because again you can choose between the modes, and also it is flexible without needing external charging because again if you run out of battery you still have fuel.
In electric drive mode, the engine is off because the battery sends electricity to electric motor, which create rotation using electromagnetic force between coil and magnet. This rotation turns the wheel so that the car can move quietly without burning fuel. Usually, this process happens when car drive at low speed, traffic jam, starting from rest and short distance. This is good for car since it have no usage of fuel and release of carbon dioxide. Next, for hybrid and combination mode, the petrol engine and electric motor works at the same time. The engine will supply main power while electric motor help provide extra power if needed. This makes acceleration faster and reduce fuel usage because the motor support engine. This process happens when overtaking cars, driving up hills and highway crashing. It gives a better power and reduce workload on engine which using low fuel. Lastly, during braking mode, the motor changes into generator. The wheel's rotation causes coil inside generator to move through a magnetic field. This produces electricity which recharges battery. This process is called regenerative braking.
Now I will explain the physics concept behind hybrid vehicles or hybrid cars. The electric motor uses magnetic field and Lorentz force. So first, electric current flows through coils of wires which creates a magnetic field. That magnetic field then interacts with magnet and produces magnetic force, which then produces a torque. That torque spins the wheel and moves the car. So electricity creates magnetic field, creates magnetic forces, which creates torque, and that makes the motor shaft rotate and spins the wheel so that the car moves. The regenerative braking system uses electromagnetic induction. So first, when the car slows down or brakes, the wheels causes the motor shaft to rotate and behave as a generator. We know by Faraday's law of electromagnetic induction that changes in the magnetic flux induces voltage in the coils. So this generated electricity is then stored in the car's battery to reuse after that. So this regenerative braking improves energy efficiency because instead of losing the kinetic energy as heat, we store it as electrical energy to save up on gas and even less charging. Next, the battery for energy storage in hybrid vehicles. So the battery obviously converts electrical energy into chemical energy to be stored and then convert it back into electrical energy when it is needed to be used. So regenerative charging, like I mentioned earlier, keeps happening even when using engine mode. So the battery keeps recharging itself to use when the car needs it. This store and release cycle allows hybrid vehicles to switch between the modes seamlessly and improves the efficiency.
Now, we would like to share about the benefit of hybrid vehicles, especially compared to conventional petrol vehicles. One of the main benefits of hybrid car is superior fuel efficiency. Unlike traditional car that rely only on petrol, hybrids use two sources of power which allow the car to optimize energy consumption. For example, during slow driving or when car is stopped, the electric motor is used instead of the petrol engine. This means less fuel is burned, which help reduce costs in the long run. Addition, when the petrol engine is working, part of the energy is used to recharge the battery, so users does not need to charge it manually. When hybrid vehicles also have lower brake maintenance due to regenerative braking. When the driver presses the brake, the electric motor switches to generator mode, slowing down the car and converting kinetic energy back to electrical energy. Because of this system, the car does not rely too much on conventional brake pads, so that the brake pads last longer and require less frequent replacement. Other than that, hybrid cars are very suitable for city driving, especially area with traffic jam or frequent stops. When the car stops at traffic light or during slow movement, the petrol engine turns off automatically and the car switches to electric mode. This means fuel is safe even while waiting and the car is quieter. Other than that, since hybrid car use less petrol, users spend much less on fuel every month. Even though hybrid car may cost more upfront, you can save more in the long term due to reduced fuel consumption. Hybrid produce fewer exhaust emission because the engine is not running all the time. This helps reduce carbon release into the air and lower air pollution. In many countries, hybrid vehicles are also promoted because they support environmental sustainability. Finally, hybrid vehicles tend to have a high resale value. Your car can still maintain a good price because hybrid technology is fuel efficiency, reliable and increasingly in demand. Many buyers look for vehicles with lower fuel usage, so hybrids maintain strong value in market. So in conclusion, hybrid car provide multiple advantages from saving fuel, reducing emission to having better long-term value. These benefits are a major reason why hybrid technology is becoming more popular worldwide.
Next, we have a challenge of hybrid car. First, hybrid car have a complex system that are harder to diagnose and fix, and also a high maintenance because of the demand of the special engine component, which is a battery and gasoline. Next, hybrid car may have a probability of battery degradation over time that can reduce the car performance. And in addition, hybrid cars are increased in weight due to the two components as engine, which is a battery and a motor. Besides, it also have a higher purchase price compared to electric vehicle and traditional gasoline car. Lastly, hybrid car needs a specialized mechanic whereby not all the mechanic are equipped in and advanced needs a hybrid service. Okay, next we have a future development and innovation. First, hybrid car needs to improve in auto drive management, where can intelligently orchestrate the operation of the internal combustion engine and electric motor. Then we can also advance a motor to power the car solidity or electricity to full saving. Besides, we need to innovate a multi-energy system to get a faster transition power and higher power density and a longer battery lifetime. Other than that, we can hyper the efficiency of regeneration to get an efficiency in kinetic energy captures. We also need to advance the hybrid architecture to seamlessly blend in the different computing environment. Furthermore, smart AI control are also required to enhance the energy and hybrid performance. In addition, hybrid also need to develop with a lightweight and a strong material by using the thermoplastic. Lastly, a quiet cabin also can be required to advance the soundproofing while driving on the road. For conclusion, a hybrid electric vehicle (HEV) integrates components from both conventional gasoline car and fully electric vehicles, leveraging this combination to offer significant fuel saving and reduce greenhouse gas emission compared to traditional internal combustion engines. This technology mitigates common concerns like range anxiety, often associated with fully electric vehicles, because HEV retains the ability to refuel quickly at existing gasoline stations. The electric battery in this vehicle is typically recharged through a regenerative braking system, which captures energy otherwise lost during deceleration. Some models known as plug-in hybrid electric vehicle (PHEV) provide the added flexibility of being recharged from an external electrical source.